At this point in our lives, most of us or someone we know has more than likely had some sort of internal injury, whether it be a broken bone, torn muscle, ligament, tendon, or something more serious. Because of these injuries, most of us have more than likely had some sort of diagnostic radiology imaging, which is a way for healthcare workers to see structures inside our body. Radiological imaging has a huge impact on healthcare. However, many people do not know how it was discovered or developed to what it was today. To begin, let's take a look at how radiological imaging was first invented. In 1895, X-rays were discovered by Wilhelm Conrad Röntgen, a professor at Würzburg University in Germany. Röntgen was working with a cathode ray tube in his laboratory and noticed a fluorescent glow emitting from crystals on a table near his tube. By experimenting with the tube, Röntgen discovered that a green fluorescent light was generated by materials located a few feet away from the tube. Röntgen determined that the tube was producing a new type of ray. This new ray was able to pass through most substances and casted shadows of solid objects. The ray could pass through human tissue, but not bone or metal objects. These X-rays were first used in industrial application, but not medical. Röntgen's discovery was a bombshell in both the scientific community and the public's eye. The public's attention was held by the ray's ability to pass through solid matter and view inner structures of the body. Scientists' attention was grabbed by the prospect of a wavelength shorter than light. His experiment could easily be duplicated because it included a cathode ray, which was widely used during this time period. Many scientists dropped their current fields of research to investigate the rays. The new ray opened doors for new possibilities in physics and investigating the structure of matter. Within a month after Röntgen's announcement of the new ray, X-rays were being implemented into healthcare. 6 months after his announcement, on the battlefield it was being used to find bullets in wounded soldiers. Now that we have seen how it was invented, we can look at the discoveries made since the first invention. In the years since Röntgen's first discovery of X-rays, many advancements were made in diagnostic radiological imaging. The first published work of a medical ultrasound was released in 1942. It was the work of Dr. Carl Theodor Dussig. Many people researched the ultrasound after his first publication. The work of Professor Ian Donald and his colleagues in Glasgow in the mid-1950s did much to facilitate the development of practical technology and applications of ultrasound. The first computed tomography, or CT or CAT scan, was developed in 1972. The CT scan was invented by two independently working scientists. The British engineer Godfrey Hounsfield invented the CT scan in England. The South African-born physicist Alan Cormack invented it in the U.S. The first magnetic resonance imaging exam, or MRI, was performed on a live human patient in 1977. Isidor Isaac Rabi developed a method of measuring magnetic properties of atomic nuclei in the 1930s. Rabi's work provided a foundation to develop MRI exams. Now that we have seen the many discoveries, we can see the impact it has on healthcare today. The development of the X-ray and the various methods of imaging has greatly impacted the abilities of healthcare workers. The ultrasound was a very important development. It was a way of obtaining pictures of structures inside the body using sound waves. The sound waves are sent through the body where they bounce off of internal organs and structures. Special instruments and computers then convert the reflected sound waves into images. Ultrasounds have revolutionized care of pregnant women. Besides pregnancy, ultrasounds can be used for imaging breast, cardiology, endocrinology, musculoskeletal, vascular, and many more structures of the body. CT scans also greatly impacted healthcare. CT scans are based on X-ray principles. The X-rays pass through the body and they are absorbed at different levels. The computers then convert where the X-rays were absorbed in the body to create an image. CT scans were an important development because they allowed doctors to see soft tissue in the body, not just bones and organs. CT scans provided a more reliable way to identify tumors, blood clots, and other abnormalities in the body. Last but not least, MRI exams were a very helpful life-saving tool for doctors. MRI exams measure the atom's nuclear magnetic movements at certain frequencies. The computers then produce an image based off of these frequencies. An MRI is an extremely useful, non-invasive method for imaging internal bodily structures and diagnosing disease. An MRI is used to image especially soft tissue, such as the tissue in the brain. Now that we have seen the various developments in radiology, we can see that it plays a very important role in healthcare today. It has saved many lives and has greatly influenced how doctors can diagnose diseases. It is a career that I especially have looked at going into, and I think it is a very important part of healthcare today. Where would we be without radiology?